Hello, and welcome to this tutorial regarding the requirements verification framework as integrated in the operational collaborative environment. The requirements verification framework is used to derive your MDAO workflow from the different requirements. Furthermore, it can be used to automatically verify your requirements based on the results that you obtain from your MDAO problem. So the first step is to add requirements to your design study within the OCE. This can be done under the Use Case Model tab and then under the Requirements tab. Here you can see an overview of all the different requirements that are present in your design study. When you add a requirement, you have to give a name to the requirement and you have to give a text. Every requirement has an ID which is automatically generated by the OCE. Furthermore, you can give a priority to the requirement, and it's very important to also specify the type of your requirement. There are 5 different types you can choose from: performance, design constraint, an environment requirement, functional requirement, or suitability requirement. Furthermore, you can indicate from which requirement or user need the current requirement is derived. So the next step is to add patterns to the different requirements. This can be done under the Requirements Pattern tab. Adding a pattern to the requirement is quite important because the different requirements need to be understandable by the requirement verification framework. And by adding patterns to the requirement, meaning is given to the different parts of the requirement, and the requirement verification framework can understand and interpret the requirement. So let's see how this works. Here you can see for different types of requirements there are different patterns, right? So for example, if we take a performance requirement, we can divide the text that we have given to this requirement, we can divide it over the patterns. So for example, we have a system, which is the flap structural elements. We have a function, which is have. We have the performance parameters, which in this case is the reserve factor. We have a performance target value, which is 1. We have a unit, and we have a performance constraint. So in this case, the reserve factor should be higher than 1, so 1 is minimum or equal. It is also important to note that your performance parameter has to be mapped to the central data schema that you are using within your MDAO workflow. So here you can see the XPath that is connected, in this case, to the parameter reserve factors. This is important to enable the automatic verification of your requirements after you have executed your MDAO problem. So after we have added the different patterns to all the requirements, the next step is to add the verification method to the requirements. This can be done under the Requirements Verification tab. So the verification of requirements consists of 2 parts. First is the means of compliance, and this indicates how a requirement is, the compliance to requirement is going to be shown. This can, for example, be by design or by expert judgment or by doing an analysis. The second part of the verification methods for a requirement is the test case. So a test case consists of all the design competences that are necessary to show compliance to a requirement given a fixed design. So for example, here you see several examples of test cases. So we can, for example, have the movable generator test case, and in this case we have connected the movable generator design competences to this test case. And this test case we can then link to a requirement, and then we can show compliance to this requirement using this test case. So once we have formulated all the different test cases, we have to connect them to the different requirements. And this can be done in this table here. So here you see again all the requirements we have added to the design study. And then if you click on Edit, you can select here the test case that is required to show compliance for this specific requirement. So now that we have all the requirements added to the OCE and we also added the verification methods to the different requirements, it's time to derive our MDAO workflow from the requirements. Okay, and this can be done in the workflow tab. And then we go to parameter rules. Because the first step when deriving your MDAO workflow from the different requirements is to add different problem roles to your requirement, right? So a requirement can be taken into account differently within an MDAO workflow. For example, it can be a constraint, but it can also be, like the second requirement, it can also be a bound on your design variable, right? So if you have the requirement that the flap shall have a rib pitch of minimum 250 millimeters, then if the rib pitch is a design variable, then this requirement can actually be bound on this design variable. So we have several other problem roles that are integrated within the OCE. So other options that we have are also objective. A requirement can also point towards a parameter that is going to be the objective in your MDAO workflow, or it can simply be a quantity of interest. Usually in a typical design case, there are thousands of requirements that you need to consider, and it's usually impossible to take all the different requirements into account during optimization. So what you can do, you can also give the requirement a problem role quantity of interest, and then all the required data that is needed to check the requirement compliance is generated after the optimization have finished. So all the data required will be there, but the requirements will not be taken into account during the optimization. Okay, so here we specify the problem roles for the different requirements. We are not required to give a problem role to all the requirements. If we don't give a problem role, then this requirement will not be taken into account during the MDAO problem formulation. So now that the problem roles are added to the different requirements, we can click on Synchronize Requirements. And when clicking on this button, the different parameters will automatically be added to the MDAO workflow, right? So the design variables will be added, the constraint variables will be added, the objective variables and the different state variables, they will all be automatically added to the OCE such that they will be taken into account during your MDAO problem formulation. And also the table is automatically filled. So for example, if we have a constraint concerning the landing distance, in this case, the constraint, we can see it here, is the aircraft shall have a maximum landing distance of 1400 meters. We gave this requirement, we gave this problem role constraint, and there you can see, okay, so the reference value is 1400 meters and the constraint type is less than. So if we refresh the page, then we can see that all the different constraints, the objective, the different state variables, and the design variables are automatically added based on the roles that you have given. Okay, so also important to mention, the requirements as you give a problem role, these variables, they are linked to a requirement. So as soon as the requirement is removed from the OCE, and you would click again synchronize requirement, then this variable will also automatically be removed. You can also manually add different constraint variables or design variables. In this case, it will automatically be set to no, it's not linked to a requirement, and these variables will always be there unless you manually remove them. Okay, so now that your variables have been added to the OCE, your MDAO workflow can be automatically generated. Of course, what we also need to know is which design competencies need to be taken into account in your MDAO workflow, right? So this is also again derived from your requirements. Because now that we have given the different problem roles to the different requirements, we know which requirements are going to be implemented in your MDAO workflow. But remember that we also gave a test case to all the different requirements. And the test cases is what we need to show the compliance to the different requirements. So your the OCE will automatically collect all the different test cases of the requirements that are taken into account, so the requirements that have a problem role, And those design competences will appear in your MDO workflow. This means that, for example, design competences that are not linked to any of the requirements that are taken into account or the requirements that don't have a problem, those design competences will not be taken into account in your MDO workflow. If you think like, okay, but I really need those design competences to solve my optimization problem, then you can go to execution order, and here you can see a setting, excluded design competences. So this is automatically be filled by the OCE as soon as you synchronize requirements. If you, for example, want the noise tool to be included, then you just deselect this. You say select, and then the noise which originally was excluded will now be included in your MDO problem formulation. Okay, so now the only step left is to actually formulate your MDO workflow, and this can be done by clicking the button Update Workflow Architecture, which is here below, and then the results we can see here under the tab Workflow. Okay, so once the workflow architecture is finished, you can see the results here below in using Vistums, and you can select here XDSM, and then here you can inspect the MDO problem as you have formulated and as it is derived from the different requirements that you have added to the OCE. So now that the workflow has been formulated, we can go to executions and we can download the commandos file here to actually execute the MDO problem that we have formulated using a workflow execution tool, like for example RCE. So once your MDO problem has been executed within RCE, you can come back to the OCE and upload your results to see whether the requirements that you have formulated are met. Okay, so how does this work? So here, for example, we have an MDO workflow that we formulated. We can add it here, we can set the status to execute it, and then here we can upload the results. Right, so we can add a result report to this MDO problem. We've done that here for several MDO problems. And then here you can select the verification file that you want to use to verify the requirements with, right? So in this case, we added the results of the MDO problem formulation that we have just formulated. Okay, so then we have the results. We can click on verify the requirements, okay? Then if we verify the requirements, you can see here all the requirements that we have added. And then the OCE will automatically check whether the requirement has been met, yes or no. For some requirements, it will not be able to check the compliance. And this can be for several reasons. But the OCE will give, as you see here, a list of all the reasons why a certain requirement, the compliance couldn't be checked, right? So for example, here we have a requirement, material definition for composite. The compliance cannot be checked because apparently we didn't set a target value, right? So then we can go back to the OCE and fix that. Okay, so once the requirements have been verified, we can see the results here. So for the ones that have been successful to check the compliance, we can see here validation is valid or invalid, depending on whether the requirement has been yet yes or no. So here we can see, for example, for the requirement, the flap structural element shall have reserve factors higher than 1. After executing the MDO problem, we have the reserve factors have the value 1.4, which means that this requirement is met, it's valid. Right, because it's higher than 1. Also, what we can see here is the compliance margin. So it shows us how far we are from the target that we have set. If it's positive, the margin, then it means that the requirement has been met, so it's okay. If it's negative, then it means that the requirement has not met. And we can see here with the compliance margin how far we are off. For example, we have a requirement that the maximum landing distance can be 1400 meters maximum, After executing the MDAO problem, we see that the landing distance is actually 1600 meters, which is not okay. So this requirement has not been met. So therefore it says here invalid, and it has a negative compliance margin. Okay, and that was it for the tutorial on the requirements verification as implemented in the operational collaborative environment.